Hey guys, good morning and welcome back to a brand new video. My name is Aditya Orange and in this video we're going to learn about quantiles and quartile. So quantile is any value which divides the dataset into a particular manner. So before that, let's think about percentile. So you have seen percentile are used for ranking. Okay. So in competitive exam we use percentile for ranking. So per 90th percentile means 90% of the students fall below this student which has 90th percentile, and 10% of the students are above him, ranks above him. Okay, so similarly 60th percentile means 60% of the total students are below him and 40% of the total students are above him in ranking. Okay. So in quantile we don't have 50th 60th, we have 0.5 0.6, so both means the same. So if we are given like find quantile at 0.5, so that is a value which divides the dataset in two equal parts. So 50% of the values will lie below it and 50% of the values will lie above it. So the dataset is first arranged in ascending order. So that's how 50% of the values, smaller values to that value, lies to the left of it, below it, and 50% of the values which are greater than it lies to the right of it. So same way, if you are given find quantile at 0.3, that means that value will have the dataset divided into two parts. So to that left of that value, 30% of the values will be there which are smaller than that value, and to the right of which that value, there will be 70% of the total values which are greater than that value, quantile value which we want to find. Similarly, if we are given find quantile at 0.65, so it will divide the dataset in two parts where 35% of the total values which are greater than it lies to the right of it, and 65% of the total values which are smaller than it lies to the left of it. Okay, so how can we find it in programming or computer? So I have this dataset here. In this data frame I have two columns, age and IQ. Okay, so total there are 10 values. So let's say if I want to find quantile at 0.5, so value which divides the dataset in two equal parts. So I have intentionally taken the values in ascending order, so it will be easier for you to understand. So first step is arrange the data in ascending order. If we want to find it on pen and paper, arrange the data in ascending order. That's the first step. Second is count the number of elements. So n you will have. So here the n is 10. 10 values are there. And third step is find the value or the position of the value. Which element is the R quantile value in the ordered data set. Ordered means arranged in ascending order. So how do you find that? So you are given Q, find at 0.4. So Q into n plus 1. N plus 1 within brackets. So first do n plus 1 and then multiply it with Q. So like you are given 0.4. Quantile at 0.4. So that quantile value into n plus 1. So I have here 10 values. So 10 plus 1 which is 11. So quantile into n plus 1. So 4.4th element is my quantile value at 0.4. So I have 4th value and 5th value. I don't have 4.4th value. So how we can find it? There are multiple ways. So one way is to find it on pen and paper. One way is round it down or round it up according to the value. So it's 4.4 rounded to 4. That's one way, and find the 4th value in ascending order. So 11, 12, 13, 14. So 14 will be my value. So we find that after rounding it up or down according to the value. Next method is I have 4.4th value is my answer. So but 4.4th there is nothing. So we do. So which it is between 4 and 5th value, no? 4 and 5th value, 4.4th element. So my quantile value will be 4th element, which is 4th element 14. 14 is my 4th element, no? 11, 12, 13, 14. 14 plus what is my fraction part? 0.4, 4.4. So 4 is my 14th value. Fourth value is 14. And then 0.4, 0.4 into fifth value minus fourth value. Okay, fifth value minus fourth value. So what is fifth value? 15 is my fifth value. So 15 minus 14. If I do this, I will get my quantile value at 0.4, which is 14.4. Okay, so this is another way, but the function used here in DataFrame quantile function doesn't give value according to any of these. Okay, first method was rounding it and using that rounded value, which is fourth element straight forward. Second is fourth element into 0.4 plus fifth element minus fourth element. This is one method, but the answer given by the quantile function is different from this. So let's see the function first. Okay, a dot, so function is this a dot quantile, and inside I am giving the quantile I want to find. So I want to find quantile at 0.4. If I do this, I get 14.6. So this is different from both of the methods. So first method would give me 14 straight up, rounding it down. Second gives me 14.4. So these are the methods of finding it on pen and paper. So they are approx method or temporary, normal methods. But this function here gives me 14.6. So let's try to find at 0.6. Okay, so it is 16.4. Let's try to find at 0.5. which is 15.5. So this is how we can use it. Now while using it, I came up with a method which was giving me these values only. So what was that? So let's say for 0.5 we want to find. So 0.5 into n plus 1. So n plus 1, 11. So I have to put multiplication sign. Okay. So 5.5. 5.5th element is my value, but I have fourth value and fifth value and sixth value, no 5.5th value. Okay, so how do we do this? So it's 0.5, so it's 50% of fifth value and 50% of sixth value. So I did this. So 15 is my fifth value, star 0.5 plus 16 star 0.5. So it gave me 15.5. We can try it for all the values. Let's say I want to find quantile at 0.6. We found it in the above expression. So let's do it for that. So quantile into n plus 1, which is this. So 6.6 is my value. So 60% of sixth value. So 16 is my sixth value plus 40% of my seventh value. If I do this, I get 16.4. Now a dot quantile at 6.6 is 16.4. So I was getting this. So just by looking at this, I came up with this. I thought it may be logical. So let's try to find at 0.2. Okay. So I get 12.8. So 0.2. So the method is 0.2 star n plus 1. So 2.2th element is my value. So 2.2 is not there. So 20% of second element and 80% of third element. So 12 is my second element, to 0.2 plus 13 is my third element, star 0.8. So I get 12.8, similar to this. So there are multiple ways of finding it on pen and paper. So it is according to what you are taught in the school, okay, or what's in the book. So which method you should use. So consult with your teacher. So multiple methods are there, okay. So it works, let's say for quantile at 0.9. So 0.9 will be value which divides the data set in two parts, to left of which 90% of the values are there, and to the right of which 10% of the values lie. Okay. So on pen and paper into 11, n plus 1, I have 11 values, 10 values, so 10 plus 1, 11, 9.9 So 90% of ninth value and 10% of 10th value. If I do this, I get 19.1. Same here I am getting. Okay. And this method also fails when I add one more decimal point. Okay. I don't know how the Quantile internal function is working, because I have searched everywhere. Either it is the first method which is rounding it off and getting the value. So if I was getting 9.9, so I round it to 10. So 10th element is my value. That is one. Second is which I showed. So 9.9 means 9th element plus difference. Oh, sorry, difference of 9th and 10th element into 0.9. So the second method which I showed, 9th element plus 0.9 into 10th element minus 9th element. Okay, and third part which I was doing this by finding how the function was giving me value. So how it fails, like if I add 0.95, so for till one decimal part it is giving me proper answer. After one decimal part, for this pen and paper method, it also fails, the third method which I thought of. So it is 19.55. Okay, so if I do this, how it is 9 quantile value star itna, so 10.45. So 10.45 is 10th element and between 10 and 11th element, but I only have 10 elements, so it fails. Even if my value is like 75, okay, so it gave me 17.75. But if I was doing with, let me show you, 0.75. So it happens when I add one more decimal point. So this one also will. It is giving me 8.25. So 8th element between 8th and 9th element. So 8th element is my 18 plus something into 9th element. So the answer I will get will be greater than 18 for sure. But here the value I am getting is 17.75. So this method fails when we add one more decimal point. So till one decimal point it is working fine. Okay. So it will be 18 into 0.25 plus 19 into 0.75. So the answer will be greater than 18 of course. But the value we are getting using function is 17.75. So that is one thing, how this function, the inbuilt function of Python, it is giving us different answer. But the process shown in the book and other forums, I showed you the three methods. Okay. So as for this function in the data frame, this is how it works. So at a time, we can find quantile for one value at one value. We can also give like quantile at let's say 0.25. If we want to find multiple quantiles, okay. So I want quantile at 0.3, 0.4, 0.5. So instead of running it 3 times, we can run it once only, okay. So let's say 0.3, 0.4, 0.5. So there are multiple values, 3 values. So I'm giving the 3 values in terms of list, okay. So I can give the values in terms of tuple also. So inside quantile function, round brackets, in terms of list I am passing 3 values. So I get 0.3. So quantile at 0.3 is 13.7, 0.4 is 14.6. Similarly for IQ also 0.3, 102.7. So 0.5, 104.5. Okay. So same here, this one also has access property. Equal to default is 0, so it is finding column wise. So for age we found quantile values, for IQ we found quantile. So if we give axis as 1, so axis equal to 1 means horizontally. So you find quantile row wise. So in row we have 2 values only, for a, 1 value is for age, another is for IQ, age IQ, age IQ. So it will give me row wise quantile value. So let's say I want just one quantile value. So for each row, 0th row, I got few values, one value, okay. So I reduced the size. So quantile at 0.5 is for 0th row or 0th index, I got 55.5. For one index, one row, I got 56.5. So my A looks like this. So for 0th of these two values, the quantile is at 0.5 is 55.5. So to the left of it, one value lies, to the right of it, one value lies, because row wise we have only two values. So we can find it row wise, column wise by giving axis values. So but logical way is to find column wise, because in a column we will have similar values, another column will refer to different values. So age, I want quantile in age only, I want quantile in IQ only. How we can do that? So how can we select a particular column like this? Then apply the function quantile 0.5. So 15.5. For age, quantile at 0.5 or 0.5 is 15.5. So for particular row also we can find. Okay. So that was quantile. Now about quartile. So quartile is a it is derived from quantile only. So if you know what is quantile, you already know quartile. So few things are there. So like if you know addition, so you can add any number. So think of quantile as addition and quartile as addition of particular numbers only. So quartile by quartile we mean 4 values. So quartiles are those values which divides the data set into 4 equal parts. Okay, 4 equal parts. So this is my one set. So this was my whole data set. This is one data set, one part of a data set, second part of data set, third part, fourth part of my data set, which are equal in size. After these values are arranged in ascending order. So first is arranged in ascending order. So what are the values? Think of this. This has one value, second, third. So these three values divide the data set in 4 equal parts. Okay. So quartile, so we have 3 values, first quartile, second quartile and third quartile. So first quartile is here. So to the left of which 25% of the total values lie, and to the right of which 75% of the total value lies. And second quartile, to the left of which 50% of the total values lie, to the right of which 50% of the total values lie. And third quartile, to the left of which 75% of the total value lies, and to the right of which 25% of the total value lies. So we have, in quartile we have 3 values, 1, 2, 3. First quartile, second, third quartile. How we can find that? Find that using the quantile function only. Okay. So here, nothing extra, same quantile function, but we are giving 3 values. So 0.25, 0.5, 0.75. 0.5 or 0.50, it means same. Because this value at 0.25 or 25th percentile value will have 25% value below it, no? And 75% value above it. At this 50 percentile or quantile at 0.5 will have 50% of the values to the left of it, 50% values to the right of it. So quantile at 0.25, 0.5 and 0.75 are my quartile. So if I do enter, so I get these 3 values. That's it. This is my quartile. Okay. I hope you got it. Go through this one more time and the 3 methods I showed you to find it on pen and paper. So on pen and paper we can find it, or we can do approx values, so it doesn't matter. On computer, this is how we do it in Python with DataFrame. Okay. Same way, same thing. If we give access value, we can find it row wise and column wise. So, and the 2 functions which were left, sum and count. So same, sum will give us access value is default value, which is 0. So it is giving us column wise sum. So for age, total sum is this. For IQ, total sum is this. We can find row wise also. So for each row, age plus IQ itna. Age plus IQ is this. Age plus IQ is this. Okay. Same thing for count. If we want to count number of elements, so age we have 10 elements, in IQ we have 10 elements. So 10 values. Same thing, if we give access equal to 1, we can find row wise. And if we want to find for particular column only, so we do this. For age, total sum is itna and total count is this. So I hope you got it. Go through this one more time if you have trouble understanding this. And thanks for watching. I will see you in the next one.